In this tutorial, we are going to do the unboxing, wiring and programming of K-1000C Pixel LED controller. Also, we are going to look into the differences between the K-1000C and T-1000S Pixel LED controllers. I'm going to unbox this controller. Alright, as you can see, it's open from the side. And I'm going to take out the contents. Alright, these are the things that is inside this box. Okay, as you can see, the Pixel LED controller, instruction manual, the SD card 256 megabytes, and the flat screwdriver to use with the terminals. If you look at this K-1000C Pixel LED controller, you can see this 7-segment display. This display will show the chip number when you press this chip selection button. If you compare this to the T-1000 Pixel LED controller, as you can see, there's a difference when it comes to the size. The height is different. This one have the display and the chip selection. This one will automatically detect the chip selection in the program or this effect file and drive the pixel LEDs. This one does not do that. You have to manually select the chip number using this button. Other than that, these two pixel LED controllers have the same specifications. 2048 pixels from this single port. They both have that specification. The power specifications are the same, except for the power consumption. This one consumes more power due to the 7-segment display. The K-1000C Pixel LED controller requires LEDEdit-K software version, and this one can be programmed using any LEDedit version. This one is expensive compared to this one. These are the differences between these two controllers. Alright, other than that, these two controllers are the same. So if you doesn't want display, you can go to a T-1000S Pixel LED controller. Alright, for this tutorial, our purpose is to show how to use this K-1000C. Now, let's start connecting the power and the pixel LED strip or the string to this pixel LED controller. For this tutorial, I'm going to supply the power through this 5-volt power supply. If you're using a power supply that have output voltage that is more than 5 volt, you need to connect power supply through this 5 to 24 terminal, the positive wire, and the ground to this middle terminal. And since I'm using the 5 volt power supply, I'm going to use this terminal. Alright, these are the power wires I'm going to use. As you can see, I have already put wire lugs on the lines. Let's connect this power supply to the Pixel LED controller. As you can see in this power supply, these three terminals are positive terminals, and these three terminals are the negative or the ground terminal. I'm going to connect the positive, which is the red, and the negative or the ground, which is the red and black wire. Now let's connect the other ends to the controller. Alright, the black and red one is the ground, and the red one is the 5 volt. Alright, as you can see, the firewall connects to these two terminals. Alright, let's connect the pixel LED strings. To connect the pixel LED strings, I'm using these JST or SM3P connectors. You can buy it online. I have already put wire lugs at the wire ends. If you are using separate power supplies, you need to connect the grounds of these power supplies together to create a common ground. Let's connect the data pin, which is the middle pin of this connector, to the pixel LED controller. And if you're controlling a LED string or strip which have a clock connection, you need to connect the clock wire to this terminal. Let's connect the power to this pixel LED string. The red one is the positive and the yellow one, in this case, the negative. Yellow one is the negative. We are not going to use one of these just 3P connectors since we are controlling only a single pixel LED string. This is the basic wiring of this pixel LED controller. Let's program this controller. I'm going to use LEDedit-K 2020 version. Double click on the LEDedit-K 2020 version desktop icon. The first thing we need to do is to create a new project. Click on File and select New Project. Alright, as you can see, we don't have this pixel LED controller in the regular use of controller list. To add that controller to this list, we need to click here, select controller. Under this, you can see we have two options, M/K -1000, M/K -8000. This is the option you need to select in order to program K-1000 C pixel LED controller. And I'm going to click here, add to add that controller to this list. So when you're selecting other controllers, you need to select the controller plus the pixel LED chip name. But in this case, since we are selecting the pixel LED chip from the controller, we don't have to do that. Only need to select the controller. Click OK. Now you can see the pixel LED controller in that list. Okay, now I'm going to use the default settings and click OK. Alright, the next thing we have to do is to create a layout. For this tutorial, I'm only going to connect the controller to a single string of pixel LEDs. In this case, I'm going to create a line layout. Click here, project configuration. I'm going to click auto layout. Okay, since we are creating a line layout, I'm going to input 50 as the horizontal pixel amount, and I'm going to input 1 as the vertical pixel amount. Then I'm going to click OK. Alright, click OK. You can see the line layout. Now it's time to program. Select the program from the list, and I'm going to select the video effect. Click here, video effect, and I'm going to click on Open SWF, or you can use Open Video also. I'm going to the location of my video or animation source. I'm going to select the animation and I'm going to click Open. This is a custom-made animation for this project. So, alright, once we have the playback on the screen, I'm going to record this animation. Alright, I'm going to stop here. Now we have recorded our animation. It's time to edit this animation. Click here, edit preview, and I'm going to pause this animation. I'm going to look where I need to start the animation. This is the frame I want to start this animation. If you look at here, we are at the 48th frame out of 107 frames. So we need to delete all the frames before 48th frame. So I'm going to click here to look where the 48th frame, and I'm going to select the 47th frame and click and hold the left mouse button while dragging your cursor towards the beginning of this frame slider. And once you select all these frames, right click and select delete. Alright, now as you can see, we are in the beginning of this animation. Now I'm going to move my slider towards the end, and I'm going to look for a place to end this animation to create a perfect loop this animation. Alright, this is the frame I want to end this animation. We are at the 53rd frame out of 61 frames. I'm going to select the frame 55 and select all the frames after that by pressing and holding my left mouse button while dragging it to the end. Right click and select delete. Alright, if you want to undo an action, right click on the frame slider and select undo. Alright, this is the edited animation. It is a perfect loop of this animation. Alright, I'm going to pause right here. I'm going to exit edit preview, and it will ask, do you want to save? I'm going to click yes. The last thing we had to do is to export this effect. You can click here or click here, export, and click export effect.led format. And I'm going to leave these settings as default and select OK. Alright, if it will ask for your location, I'm going to select desktop and I'm going to click OK. Alright, now we have this folder created by the LEDedit software. Go inside, copy the LED effect file, paste it on your SD card. Okay, if you have noticed this icon, we are not in a Windows XP machine. This is a virtual machine on Windows 10 OS. You might ask why I use a virtual machine in my Windows 10 OS, because previous versions of LEDedit does not support Windows 10 or later versions of Windows. So we had to create a virtual machine in order to run LEDedit software without problems. So that's why I'm using a virtual machine. Now copy the files to my SD card. I'm going to plug the SD card to my PC. Alright, I'm going to select connect to the virtual machine, and I'm going to select the OS and click OK. Alright, now I'm going to copy the effect file and I'm going to paste it on the SD card. Alright, sometimes it appears, sometimes it doesn't. Alright, now you can see it appears on the virtual machine. I'm going to paste it here, paste the effect file on the SD card. Alright, sometimes it doesn't work. However, if it doesn't work, you can copy this LED effect file or effect folder to your Windows 10 PC. I'm going to copy it and I'm going to minimize the virtual machine software. I can paste the effect file in my Windows 10 PC. That's how you transfer files from the virtual machine to the Windows 10. It's very easy. If you want to know how to install a virtual XP in your Windows 10 or later version of Windows OS, check out the video in the description. Let's connect the Pixel LED string to the Pixel LED controller. This is WS2811 Pixel LED string. I'm going to connect the first Pixel LED to the JST connector from the Pixel LED controller. Alright, like that. Now you can see the data line is coming from the controller. The power for the Pixel LED string is coming from the common power supply. Let's turn on this power supply and see what will happen. Alright, as you can see, the Pixel LED string is now playing the pattern inside this SD card, we need to select the correct chip group for this pixel LED string from the pixel LED controller using the chip selection button. But first, let me show you what are these numbers in the 7-segment display means. These first 2 digits shows the chip group, and the second 2 digits displays the program number, and the last 2 digits displays the speed. As you can see, you can increase or decrease this speed. To select the chip group, we can press this chip selection button. This is the chip group number, and this is the chip number that in that group. Don't put too much attention to the number. Just focus on the group number. As you can see, we are in the 3rd group. It is not the group we want, right? In the 4th group, is still no playback of the effect inside the SD card. I'm going to the 5th group. As you can see, it's still not the pattern we want. I'm going to the 6th group. Alright, now you can see the pattern. This is the correct pattern of the effect file inside this SD card playing on this pixel LED string. So for WS2811, the correct chip group is 6. Let's try other groups as well. I'm going to the 7th group, group number 8, group number 9. We have the pattern movement, but not the colors we want. The pattern group 0 also have the same data protocol that WS2811 chip can read. So as you can see, we have 2 groups that support the same pixel LED string. That's how you program K-1000C pixel LED controller. For more detailed version of this tutorial, check out the website article below in the description. If you like this video, please leave a like. If you like this channel, please subscribe. Thank you for watching. See you in another tutorial.